Hello, welcome to Notes7.com. We're the Notes7 Creative Engineering School, so welcome to this lesson. We always start out with a riddle or a puzzle or a math question. Some of our math questions or riddles have to do with other classes, so if you watch some of the other classes, you'll be able to solve today's problem. Um, the first thing you need to know about any riddle or question, the only reason it's interesting is it's because it's not at all what you think it is at first. So your first instincts are wrong. That's why we like riddles so much, because it sparks the creativity. So when you look at something wrong or see something wrong and you think, oh wow, I thought it was something else, use that as your creativity. Maybe it should have been something else, and that could lead to an invention. Okay, so anyway, if you have any questions, comments, or if you have the answer to the riddle, post it at notes7@gmail.com. Send us an email, and if you get it right or a better answer than what we figured, we'll post that too. Okay, so today's puzzle, I may ask a couple of different ones. So I'll give you a real story, and this is something that happened to me. So 3 Christmases ago, I think it was three, I was asked to make a potluck dinner and bring over spaghetti and meatballs. So I had a certain fixed amount of hamburger meat, okay, and actually when I make my meatballs, I put a bunch of stuff in it. So for the sake of argument, let's say it's 2 pounds. I have no idea. I didn't know how much it was. A limited amount of meat. And so typically I make 1 inch diameter meatballs, and I thought, you know what? Instead of making all these 1 inch diameter meatballs, I could probably make about 24 1 inch diameter meatballs. I thought everybody likes bigger meatballs. I'm going to make bigger meatballs. So I decided to make 2 inch diameter meatballs instead of 1 inch. I quickly put the math to this problem and thought, well, if I make if I have a limited amount of meat and make 24 1 inch, how many 2 inch meatballs could I make with that same meat? Okay, so that's the riddle and the question. I don't know if it's a riddle, more of a mathematical question. How many meatballs could I make with the same material, in this case meat, of 2 inch diameter meatballs? Okay, it's that simple. Okay, so along that, I'm going to give a second puzzle that's very similar, and it has to do with, let's say, in this case, remember the meatballs we're assuming are a perfect sphere, and this is the same thing. So a perfect sphere, let's say it's the sun or a planet, and let's say we have the earth, okay? But in this case, it's not the sun and the earth. So we have one sphere that we'll say is 1 unit. It could be one anything. In this case, we'll say 1 foot, okay? And then we have this bigger sphere that if we go all the way from top to the bottom, it's 10 feet. But this could be 1 mile, 10 miles. This could be any unit. So it really doesn't matter because units drop out. So what is the volume? How much greater is the volume of this large sphere greater than the small sphere? We know the diameter is 10 times bigger, so that holds true. It doesn't matter whether this is a golf ball and a basketball, or this is the earth and the sun. If we just compare the diameters, how much bigger is in volume is this one and this one? So the volume of this we'll call 1, and the volume of this we'll call 2. And what we want to know is you take V2 over V1 and it gives us a number. Is it 10 times bigger? Is it 5 times bigger? Is it 100 times bigger? What is the differential? Okay, so that's what we're looking for as far as an answer. Okay, so that's volume. It's a sort of a puzzle. We just want you to get really good at this stuff, and it is counterintuitive, that's for sure. Where that can come in handy, let's say you're making a rubber ball or something for a business you're in, anything that has material, and by just adding a little bit more in the diameter, or the same thing comes true if you're doing a cube, you have to be amazed at how much more material you use when you enlarge, or how much you save when you decrease just a little bit. Okay, so that's how it's useful in real life. Okay, so today we're going to have just a fun adventure of, we were talking a little bit about the sun and the earth, and so the way this ties in, of course, we all know that the earth revolves around the sun. Okay, it's an orbit, elliptical orbit. This is the earth. And so what we know is it's 365 days. Now, the reality is, we always think people in the past were dumb. No, people in the past were super smart. They just didn't have as many historical books and mathematical, so we're building on that. But people were super smart. In fact, in 44 BC, under Julius Caesar, so this is over 2,060 years ago, they just found out, you know, a lot of people say that people thought the earth was flat. Well, how come, 600 years before that, they had already figured out how long it takes the earth to go around the sun? I don't know how they did it, but they did. So they found out that it doesn't take 365, it takes 365.25. So that's when, in 44 BC, we called it the Julian calendar under Julius Caesar. That's what July is named after also. And then August is named after Augustus Caesar. August and July, Julius, and Augustus. So this is when leap year was discovered. So every year after that, every fourth year, because if you take 0.25 times 4, there's an extra day created. So every 4 years, we add a day. We all know it's February 29th. It's to make up for this. They figured that out 2,060 years ago. Okay. Now, that's pretty common knowledge, except for when it was actually discovered, which is crazy. Okay. Now, in 1582, something else happened, and this is less familiar. There was Pope Gregory VIII. And under Pope Gregory, they discovered, so who's ever in charge sort of gets the credit. It's not like Julius Caesar knew anything, or Pope Gregory VIII knew anything, but the scientists or whoever to be discovered that, oh, it's not 365.25, it's 365.2425. That's under 0.25. So now, here we go, 44 BC, and then here we come, 1582. They've been doing it wrong all this time. So because it's BC, in the year of the Lord, AD, Autos Domini, which means in the year of the Lord, when Jesus was born, this is the big divider, 1582 plus 44. So this is over 1,600 years later, they decide, whoops, we made a mistake. So now it's, at this point, it's October, it's actually a Thursday, October 4th, 1582, and they had to declare the next day they were going to keep in sequential, so it was still Friday. This is the crazy thing, became October 15th, 1582. So they had to skip 10 days. So can you imagine going to bed Thursday night, it's October 4th. That next Friday, it's October 15th. Those are 10 days in history that never existed. So nobody was born October 5th through the 14th in 1582. Those days did not exist. So they had to make up for this little loss that happens almost every 100 years. So now today, on year 1600, they have to skip. So every 100 years, they actually do not celebrate leap year. So in 1600, and in 2000 and in 2400, they still do. Everything that's divisible by 4, 2800. So on these dates in the future, we will still do it. So we miss it in our lifetime. 2400, we'll continue to have a leap year, 2800. But every other calendar year, we'll skip a leap year on that year. So 2100, 2200, 2300. In the year 2300, February, there will not be a February 29th, because that would be when a leap year happens. So there is a leap year not celebrated, if you call it celebrated, every 100 years, except for if they're divisible by 400. And that puts us right at that number. So that's the Gregorian calendar. What difference does it make? Well, it's a fun fact. We should know what we're on the Gregorian calendar, not the Julian calendar, when they were originally came up with, how smart people were, and I don't think they thought the earth was flat. So anyway, that is the lesson for today, and we're going to be talking a lot more about the earth and the sun, the moon, lunar days, earth days, and some of the ways that you can work backwards in time, and we need to know about these 10 missing days when we start working things backwards from today. Okay, that's it for today. I hope you enjoyed it. Send in your answers to the puzzles, the 2 of them today, Notes7 school@gmail.com, and we hope you enjoyed today's lesson. Thank you. Okay, see ya.